Good day and welcome to our channel. So today we'll be doing mathematics paper 1 preparatory exam from 2023. Do not forget to subscribe, like, share and comment on our videos. Also share with your friends who are doing the same subject and grades. So the first one we are having solve for x. So now here we are given 2x, it's into 2x plus 1, and then all that is squared minus 4 equals 0. Now, when you look at this particular question, you can actually expand this bracket and then you factorize that, or you can simply transpose, therefore, since it's a perfect square, and then you introduce the plus minus square root and then you solve for the value of x. So let's just do the simple one, which is transposing the negative 4. So we'll be having 2x plus 1 squared equals 4. Then from there you introduce the plus minus square root, so you'll be having 2x plus 1 equals 2, or 2x plus 1 equals negative 2. So you just introduced a square root both sides to get rid of this squared, and then this one was plus or minus, so hence the plus 2 and the minus 2. Then from there we've got 2x equals 2 minus 1, it gives us 1, and then you divide by 2 both sides, divide by 2, so your x is equals to half. Then the other one, you've got 2x is equals to, so transposing the 1 to that side is going to give us negative 2 minus 1, which will give us negative 3, and then you divide by 2 both sides, and then your x is equals to negative 3 over 2. And then we move to 1.1.2. so our 1.1.2 says 4x squared minus 11 is equals to negative 12x. So you just transpose the negative 12x to the left hand side, and then you factorize if possible, or if not you can just use, or since there's a correct 2 decimal places, you are now going to use what? You are going to use the quadratic. For our quadratic formula says x equals negative b plus or minus the root of b squared minus 4ac, all that is over 2a. So when you transpose this to the other side, you are going to have an equation like this. It's 4x squared minus 11, or it's going to be plus 12x. Let's just write it in the correct form, which is ax squared plus bx plus c. So this one is going to be plus 12x because it went from the right hand side to the left hand side, and then here we've got minus 11, and all this equals 0. So you know that your a is 4, your b is 12, and your c is negative 11. So you just substitute them there, and then you find the value of x. Now the value of x is going to be it's negative into 4 so it's negative b, so it's negative into 12 plus the root of 12 squared minus 4 into the a is 4 into c, and our c is 11, or negative 11. So make sure that you include the signs as well there, so that you do not come up with a wrong answer. So 2a is 2 into 4. And then we get 0.74. So the first one is 0.74. And the second one, x is equals to, so you just change the plus to minus, and then you've got yourself negative 3.74. Negative 3.74. Then we go to 1.1.3, which says 15x minus 4 is less than 9x squared. So let me just rewrite that. It's 15x minus 4. All this is less than 9x squared. And then we can now transpose this to the left hand side. It becomes negative 9x squared plus 15x minus 4 is less than 0. And then obviously we are not used to factorizing with a negative a, so we just divide by negative 1 throughout. So it's 9x squared minus 15x plus 4 is greater than 0. So you know that if you divide by a negative number, the value there or the sign there changes. If it was less than, it becomes greater than, and vice versa. And then from there, we can now try to factorize this. You can use the twin tower, where you find the factors of a and c. A is 9, so the factors of 9, it's 9 and 1, 3 and 3. And then this side we've got 4, which is going to be 4 and 1, 2 and 2, and then we can just interchange the 4 and 1 to 1 and 4. And then we want factors when cross multiplied and those products are added, they give us 15. So let's just do this. 3 times 1 is 3. 3 times 4 is 12. 3 plus 12, do we get 15? Definitely we get 15. So this is going to be our first bracket, and this is going to be our second bracket, and these ones, they're going to have our x values there, or our x variable there. So let me just remove this. And then now we've got 3x that goes with 4, and then we've got 3x that goes with 1. And then all this we said is greater than 0. And then now let's find the final answers for the signs. The final answer here is going to be 1 over 3. The final answer there is going to be 4 over 3. And then the 1 over 3 is 0, 33333, and then this one is 1 comma something. So we know that this one is actually bigger than this one. So this one says our signs are the same. This one is saying the signs are negative. So there's actually no need for us to find the bigger and the smaller because of this plus, since the plus says to us the signs are the same. And then now we look at this. We know that this is actually our parabolic function, and then these are our answers. So we can just say, let's find the critical values, and then x is equals to, and then we've got positive 4 over 3, and then our x is equals to, and then we've got 1 over 3. So we actually have something like this. So this is our 1 over 3, and this is our 4 over 3. And then since our a is positive, we know that it's going to be a smiling graph. So we are going to have something like this. And then now we go back to this. What are we looking for? We are looking for where our graph is positive. Where is our graph positive? Above the x-axis, because we know that y, this is y, the y-axis, and we know the y is positive there and negative there. So above it's positive, and then below it's negative. So from 1 over 3 all the way to the left, how is our y values? How is our graph? So our graph is on top, so that means it's positive. And then we look between 1 over 3 and 4 over 3. So in between, it's obviously here, so it's negative. And then from 4 over 3 to the right, it's positive. And then where are we looking for? The values of x, for where our graph, our y, is greater than 0. So it's positive. So that means these numbers. And we know these numbers are less than 1 over 3, and these numbers are greater than 4 over 3. So our answers are going to be two separate answers. So our x is less than 1 over 3, and our x is greater than 4 over 3. So you cannot write these as 1. You cannot combine these two because you do not have a number that is less than 1 over 3 and greater than 4 over 3 at the same time. So we move to 1.1.4. So our 1.1.4 says to us the root of 2x minus 2, and then minus the root of 7 minus 2x, all this is equals to 1. Now when you look at this question, you can see that it's similar to the one that you did in grade 11. So the only difference is that we've got two square root signs there. So you can just transpose this one because you can see, oh, we can transpose that one because it's going to be positive when it gets to the other side. So we've got square root of 2x minus 2 equals, then this comes as it is, but now it's going to be positive, 7 minus 2x plus 1. And then now we can square both sides to get rid of the square roots. And then this side you square that. And then from there, for this one, the square root is going to be cancelled by the square. Then you just have 2x minus 2. Now for this one, let me just make some space for it there, and then we deal with it. So we've got the root of 7 minus 2x plus 1. All this is multiplied by itself. Root of 7 minus 2x plus 1. Now this times this is just going to be what is under the square root. So we've got 7 minus 2x. And then this times 1 is going to be this as it is. And then this times this is going to be that as it is. So you can see that we've got two of these things. So we can just say it's plus 2 root 7 minus 2x. And then 1 times 1 is plus 1. So this is what we've got on the right hand side there. So it's 7 minus 2x plus 2 root of 7 minus 2x, and then plus 1. And then we can transpose everything that doesn't have the square root to the other side. And then this 2x goes that side, it becomes 4x. So it's this 2x and that 2x. And then negative 2 minus 7. Okay, let me just say minus 8, since we've got 7 plus 1, which is 8. And then negative 2 plus 8. Or this plus 8 is positive from this side. When I transpose it, it becomes negative. And then it's minus 10. All this is equals to 2 root of 7 minus 2x. Now we square again to get rid of this guy. Or we can actually just get rid of these two to simplify things there. Now, how is this going to be? It's going to be 2x minus 5 equals root of 7 minus 2x. And then let me just remove everything here. Okay, the segment remover. Okay, it won't work like that. Let me do the stroke remover. What is happening now? So it's 7 minus 2x there. And then we square both sides now. It's square. Even this side, it's square. And then now we get the left hand side, it's 4x squared. Remember, you've got these 2x times 5, negative 5, it's negative 10 in the other one, so it's minus 20x. And then the 5, negative 5 and negative 5 is positive 25. And then all this is equals to 7 minus 2x. And then we take these to the other side, and then we've got 4x squared and minus 20x plus 2x plus 25 minus 7 equals 0. Then it's 4x squared minus 18x plus the 25 minus 7 gives us 18. So it's plus 18. All this equals to 0. And then we can divide by 2, and then we have 2x squared minus 18 over 2, it's 9x, and then plus 9 equals 0. Then let's just not waste time with this. Let us punch this on our quadratic equation. Plus minus the root of b squared minus 4ac, all that is over 2a. And the x is equals to, or the x is equals to. So our a is 2, b negative 9, c positive 9. So we've got negative into negative 9 plus the root of negative 9 squared minus 4 into 2 into 9. All that is over 2 into 2. Okay, and then the first answer is 3, and the second answer, just change the plus to minus, I get 3 over 2. And then now we know that with questions like this, there's always, or most of the time, there's an answer that doesn't work between these two. So if you were to substitute there, and then you'd find that one of these is not going to make this equation to be true, and then it's a mark that you found that. And then for this one, it's the 3 over 2, so the x is not equals to that, so you get an extra mark for that. So out of 5, you are going to get 4 if you didn't show that. And then we move to 1.2. Now 1.2, we've got a squared b squared minus 2ab minus 8 equals 0. They say this is our equation 1. And then the second one is log a plus 5 base 2 equals 3. And this is our equation 2. Now from this one, the second one, you tell us that this is from equation 2. And we know that we can change the logarithmic to exponential, and then the base remains the base, so it's 2 exponent 3 is equals to a plus 5. So we actually have 8 is equals to a plus 5, then a is equals to 8 minus 5, which is 3. So we already have our A. Now we just have to find our B from this one, the equation 1. So it's going to be 3 squared B squared minus 2 into 3B minus 8 equals 0. Then this is 9. So we've got 9B squared and then minus 6B minus 8 equals 0. Then we can do the same thing that we did on the first one there, finding or using the quadratic formula. That's negative b plus minus, just to keep things simple, or we can actually use the A and C there. But because we already started with our quadratic, let's just use it. So it's negative into negative 6 plus the root of negative 6 squared minus 4 into A is 9, C is negative 8, and then you close the bracket, it's 2 into 9. Then the answer there becomes 4 over 3. And then the other one, oh, by the way, these are B's, not X. So this is B, and this is B. And then the other B, change the plus to minus, and then you get negative 2 over 3. And then now you can check from these ones. Okay, we can actually just write the answers there as A and B are 3 and 4 over 3. The other one, it's with the same A, right? So you can just write the 3 again there. And then the Y is negative 2 over 3. And then we move to 1.3. Now 1.3 says, if P is root of x over 2 over root of 16 minus x squared, so it's root of x plus 2 over root of 16 minus x squared. For which values of x will P be real? Now find the definition of real and the opposite, obviously, which is non-real. We know that non-real are radical signs that have an even degree there and a radicand that is negative. So as long as the radicand is greater than or equals to 0, then we know that our roots are going to be real. But now in the denominator, we cannot afford to have 0. So now we can just say the first one, this one should be greater or equals to 0. It can be 0. So x plus 2 is greater or equals to 0. And then x should be greater or equals to negative 2. And then we go to the second one, which will be 16 minus x squared. This one should only be greater than 0, because if it's 0, then the whole thing is going to be over 0, and then that is undefined. It's not real as they said. So we've got, we can actually just do that. Difference of 2 squares, 4x, and then plus minus. And then we know that this is going to be something of this nature. So we are going to have a negative 4 there, and then we are going to have positive 4 there, and then since this is negative, it's going to be something like this. And then we are looking for where this is greater than 0. So where it's greater than 0, it must be above. So that means we are actually looking at these x values. So for this one, x should be greater than negative 4 but less than positive 4. So for this one, you don't include these guys because they make these denominator to be 0. And then we are done with our question 1. Now our question 2 says the following is an arithmetic sequence: 1 minus p, 2p minus 3, p plus 5, meaning if they say it's an arithmetic, we know that the difference between consecutive terms is constant. So when you say t2 minus t1, you get the same answer as t3 minus t2. And then they say calculate the value of p. So we just say t2 minus t1 equals t3 minus t2, and then we solve for the value of p. So our t2 is 2p minus 3 minus, then we can put the t1 in brackets because it has two terms. Then it's 1 minus p. All this is equals to t3 minus t2, which is p plus 5, minus into the t2 is 2p minus 3. So if you do not put in these brackets, you're obviously going to get a wrong answer because this minus affects both the terms in the bracket. So we've got 2p plus p. I'm just removing them like this and putting them in pairs. And then minus 3 minus 1 equals p minus 2p plus 5 plus 3. Then 2p plus p is 3p minus 4 equals 2p minus that, it's negative p plus 8. Then we take the negative p to that side, the 4 to that side, and then we've got 4p. Okay, so it's 3p plus p equals 8 plus 4. And then we can say now we divide by 4 both sides by 4. So we know that this is 4p, and then we're left with p is equals to, and then this is 12 over 4, it's 3. So our p is 3. So they say write down the value of the first term of the sequence and then the common difference. So 2.1.2, we just substitute the p there. So 1 minus 3 gives us negative 2. And then 2 times 3 is 6. 6 minus 3 is 3. And then 3 plus 5 is 8. And then now let us find our difference. 3 minus negative 2 is 5. 8 minus 3 is 5. Then you can also find the other terms by adding 5. Explain why none of the numbers in this arithmetic sequence are perfect squares. So why do you say that none of these numbers are going to be perfect squares? So we can just find the equation of the general formula, and if it doesn't give you something like that, and then you know that none of these are going to be perfect squares. So let us just calculate that. Tn is equals to 5n, that is dn, which is what you did in grade 10. So it's 5n, and then if I substitute 1 here, 5 times 1, I get positive 5. What must I add or subtract in order for me to end up with negative 2? So I'm supposed to subtract 7. Is it 7? 5 minus 7 is negative 2, yes. So this is the general formula for this. So no square number, no perfect square. You know that your square numbers, they just have that square there. And then 2.2 says the following sequence of numbers forms a quadratic. So now we've got a quadratic. You know that for a quadratic you've got the first difference and a second constant difference. So here is negative 2, and then there you've got negative 3 again, and then you've got negative 6, and then you've got negative 11. Then they say the first differences. So they are talking about the first differences, which we know they're going to be there. So what about the first differences? The first differences of the above sequence also form a sequence. We know that the first differences of a quadratic are giving us an arithmetic. Determine an expression for the general term of the first differences. So you must be very careful to answer what they asked you. Negative 2 minus negative 3 is going to be 3 minus that, it gives us 1. And then negative 3 minus negative 2, it gives us negative 1. Negative 6 minus negative 3, it gives us negative 3. Negative 11 minus negative 6, it gives us positive 5. Oh, it's supposed to be negative 11 minus that, so it's negative 5. And then now let's find the difference there. Negative 1 minus 1, negative 2. Negative 3 minus negative 1, it's negative 2. Negative 5 minus negative 3, it's negative 2. So this is the pattern that they were talking about there. So the pattern is an arithmetic. So it's 1, negative 1, negative 3, negative 5, and then you can now find the difference, which is negative 2, negative 2, negative 2. You know Tn is equals to a plus into n minus 1, close the bracket, d. The Tn is equals to the a is the first term, so it's 1 plus into n minus 1, close the bracket. The d is negative 2, so just put it in brackets. And then you multiply out your Tn is equals to negative 2n, so I'm just multiplying those out first. And then plus 2 plus 1, and then this gives us negative 2n plus 3. So this is the general formula for the first difference thing. And then let us move to the next question, which says, calculate the first difference between 35 or the 35th and the 36th term. Now let us see what is happening between the positions of this original and these first differences. Now we say this is term 1. Okay, what is happening now? This is term 1, this is term 2, this is term 3, this is term 4, this is term 5. Now we can see that the first term in these first differences is between term 1 and term 2. And then the second one is between term 2 and term 3. The third one is between term 3 and term 4. So if they say between 35 and 36, that means they're actually looking for term 35 in the first difference. So we can just substitute there our 35. So T35 equals negative 2 into 35 plus 3. And then what do we get there? So negative 2 into 35, and we get 70, and then negative 70 plus 3 is negative 67. So we've got negative 67. And then they say to us now, determine an expression for the nth term of the quadratic sequence. So now we are looking for this one, the general formula for this one, which we know it gives us Tn is equals to an squared plus bn plus c. So now we have to find these, and we know that we always say 2a is equals to the second difference. In this case it's negative 2, and then 3a plus b equals the first difference, which is 1, and then a plus b plus c equals the first term, negative 3. So the first one, a is equals to, you just divide by 2 both sides, it's negative 1. And then this one, substitute a negative 1 there, and then it's 3 into negative 1, it gives you negative 3. You transpose to the other side, it becomes positive. So b is equals to 1 plus 3, which is 4. Now for the value of c, we just substitute the a there, which is negative 1, the b, which is positive 4, and then plus c equals negative 3. Then this gives us 3, and then this positive 3 goes that side, it becomes negative. So c is equals to negative 6. And then from there we can now write our formula there. So our formula is, on the a we've got negative, so it's negative n squared plus 4n minus 6, and then we're done with this one. Then they say 2.2.4, show that the sequence of numbers will never contain a positive term. So now we can just find, since they say I will never have a positive term. And then when you look at this, you can see that you've got a graph like that. So they're actually looking for the maximum, or the term that has a maximum value. And you know that you find the first derivative equated to 0 and solve for the value of n, substitute the original equation, or you can just use the equation to find the axis of symmetry for a parabolic function. So you know that your n is going to be negative b over 2a, which is negative into 4, all that is over 2 into our a is negative 1. Then the negative 4 over negative 2 is positive 2. So the negative, or the maximum value here, is term number 2. So term number 2 is negative 2. So that is the maximum. So T2 is equals to, you can now substitute that there, and then you are supposed to get that negative 2. So it doesn't go above this. So this is the maximum. So it's never going to be positive. And then you're done with that. Question 2.